So let's choose another measuring device. This time, let's choose a meter stick. Let's choose a meter stick. So let's say this meter stick is this long. And this meter stick, we could record to, we'll just say that is 1 meter right there. Now, if I ask you my height, what would you say my height is? Okay, so you would probably say my height is, well, I'm definitely taller than 1 meter. So let me write that down as 1 meter is less than Mel's height. And would you say it's fair to say that I'm shorter than 2 meters? Yeah, I think that's a fair thing to say. So I am shorter than 2 meters in height. Now, the problem is we don't quite know exactly where I fit within the 1 to 2 meters. Am I closer to 1 meter? Am I closer to 2 meters? Maybe I'm somewhere right in the middle. Well, take a look at the meter stick. We could probably estimate something reasonably to maybe the nearest half of that meter stick. So let's look at this halfway point. Notice my waistline is approximately at about the halfway mark of the meter stick. So, let's see if we could reasonably estimate my height to the nearest half meter. So when I'm looking at this, when I'm looking at my meter stick, all I know is my meter stick is 1 meter tall. But I think I could reasonably estimate to the nearest half of a meter. So with that said, I am going to estimate that my height, Mel's height, is 1.5 meters. But because I am estimating to the nearest half a meter, that is a little bit of uncertainty into this problem. That means that my height can be as short as 1 meter, which we know I'm no shorter than 1 meter, or as tall as 2 meters, and we know from our meter stick I am definitely not taller than 2 meters. So right now, our best estimate that we could reasonably make is 1.5 meters, and our uncertainty is half a meter. And there I go again, can't spell for certain uncertainty. So let's see how close we can get with this. I am just going to take my meter stick. I'm going to make another one exactly the same. And let's see if we are pretty close. I'm going to move this over here. Move this over here. And you know what? We're not exactly halfway, because the halfway mark is right here approximately. But we are pretty close to that halfway. You and I were able to reasonably report that my height was to the nearest half of a meter stick to be 1.5 meters plus or minus half a meter. So here's the thing. There's a convention that we follow. First off, only report what you can reliably measure. And I guess what I mean by that is always report your level of certainty in a particular measurement. Your level of certainty is indicated by the uncertainty. So uncertainty, remember, provides a range of values to where you believe the true value to lie within. So in this example, my true value, I'm somewhere between 1 meter and 2 meters high. Now, because our smallest division of measure was 1 meter, if we are able to do so, and only if we are able to do so, if we are able to estimate to within half of that smallest division of measure, then we can do that. So even though my meter stick, all I know for sure is that it is exactly 1 meter tall, you and I can reasonably measure to about half of that. So we could report our uncertainty to the nearest 1/2 of the smallest division of measure and the fine print is only if we can reliably do so. So if we could only reliably measure to the nearest 1 meter, then we report to the nearest 1 meter. If we could only reliably measure to the nearest 5 meters, we only report to the nearest 5 meters. Let's say we could reliably measure to the nearest 1/4 of a meter. So let's go ahead and put the halfway division and say that that is exactly halfway. Well, from here, we could probably say we could make my measurement to the nearest 1/4 of a unit. So a 1/4 of a unit would look somewhere between there and somewhere between there. So notice if we look at this range says that I am somewhere between 1.25 meters and 1.75 meters. So here we're measuring to the nearest 1/4, where we could do a best estimate. We could say the best estimate is still 1.50 meters. Now definitely we're not at 1.50 exactly. We're a little bit above 1.50. But because now we're saying we're able to measure reliably to the nearest 1/4 of a meter, we could do our best estimate to the nearest 1/4 of a meter. So this is what it would look like. I'll first start with the uncertainty. The uncertainty is 0.25 meters because we're measuring to the nearest 1/4 meter. And from this, I could see that I am at 1.5 meters tall. That's my best estimate. One thing I want you to notice from here is that the number of decimal places in our uncertainty fixes the number of decimal places in our best estimate. If we're measuring to the nearest 0.25, then the hundredths place means that we could do our best measurement. We round our best measurement to the hundredths. If we are saying our uncertainty is 0.5 meters, then we report to the nearest 0.5 meters. The uncertainty fixes the precision of our best estimate. And in this situation, notice how the 0.25 meters is equal to 1/2 of half a meter. Now, remember when we added our halfway mark? That was half a meter. This was our estimate away from half a meter. 1/2 of 1/2 is 1/4. So this follows this guideline. As long as we're able to reliably do so, we could measure to the nearest 1/2 of the smallest division of measure. And so if our smallest division of measure is a half meter, and we can reliably estimate to the nearest half meter, or let me rephrase that. If our smallest division of measure is the half meter, and we can reliably estimate to the nearest half of a half meter, then we can report that. And for this one, that is to the nearest 1/4 of a meter.